So the fourth colligative property we are going to study is the osmotic pressure, which is given by symbol pi. And now, before starting with osmotic pressure, we'll understand some terms like number one, what is osmosis? I hope everyone has learned what is osmosis. It is said to be a spontaneous flow of solvent molecule from one compartment to another, but that is what lower concentration to higher concentration through the semi-permeable membrane. So we can define as the spontaneous net flow of solvent molecule from lower concentration to higher concentration through a semi-permeable membrane. Clear? That's called osmosis. Now, what is osmotic pressure? The pressure needed to stop the osmosis. In very simple term, I'm saying the pressure required to stop osmosis is said to be osmotic pressure. That means the pressure at which there is no net flow of solvent molecule from lower concentration to higher concentration is said to be osmosis, also osmotic pressure. So उसका भी definition देखते हैं. So osmotic pressure, which is given by symbol pi, can be defined as the external pressure which must be applied on the solution in order to stop the flow of solvent molecule. Or we can say to stop the osmosis. Clear? Next, types of solution based on osmotic pressure. So, number one, isotonic solution. Second, hypertonic solution. And third, hypertonic solution. So what is isotonic? That means when two solutions have same osmotic pressure, it is said to be isotonic. If they having higher osmotic pressure called as hypertonic, low osmotic pressure called as hypertonic. So if I define isotonic solution, so I can say that two or more solutions having same osmotic pressure. Hypertonic, the solution having higher osmotic pressure. And hypertonic, solution having lower osmotic pressure. Clear? अच्छा, एक और टर्म होता है रिवर्स ऑस्मोसिस, अगर सबने सुना होगा रिवर्स ऑस्मोसिस, like the pressure at which there is no osmosis is called as osmotic pressure, correct? But अगर वही pressure से ज्यादा अगर आप pressure apply कर दो, there will be a reverse flow of the solvent molecule from higher concentration to lower concentration through the semi-permeable membrane, and that's called the reverse osmosis, which is used to purify the solution. Clear? Is everyone clear? So next we'll see the Ventoff general equation. Ventoff general equation. Now it's a very simple equation which is actually formed on gas equation. अगर आपने याद है, so according to gas equation, क्या था gas equation? PV is equal to nRT. Now it is modified by changing the P by pi. So now the equation is pi V into, sorry, pi V is equal to N2RT. Now here we have taken N2 to relate with the solute, because we say colligative property is related with the concentration of solute particle. So now this equation is called as Ventoff general equation. Ventoff general equation. Okay. So pi is said to be osmotic pressure, which is measured in ATM, the unit ATM. Volume, V stand for volume of solution measured in liter. Number of N2 सबको पता है. N2 stand for number of moles of solute, correct? R stand for the constant, जिसका value अब यहाँ पे use करोगे 0.0821 liter ATM mole inverse Kelvin inverse, and T stand for the temperature, and the unit for temperature should be in Kelvin. Okay, तो अब इसमें like मेरे पास इक्वेशन है pi v is equal to n2RT. So we can say pi is equal to n2 upon v into RT. क्या मैं ऐसे लिख सकता हूँ, where n2 by RT, n2 by v is equal to concentration. Yes or no? I can write as C. या हम उसको मोलैरिटी भी लिख सकते हैं, बिकॉज वॉल्यूम यहाँ पे लीटर में, तो मोलैरिटी का फॉर्मूला भी यूज कर सकते हैं, कोई इशू नहीं है यहाँ पे। C स्टैंड फॉर कॉन्सेंट्रेशन, M स्टैंड फॉर मोलैरिटी, मैं यहाँ पे लिख देता हूँ M स्टैंड फॉर मोलैरिटी, ठीक है। So my equation get changed to pi is equal to CRT, or you can write as pi is equal to MRT. So as you can see, in both the equation, we say osmotic pressure is directly proportional to C. Similarly, osmotic pressure is directly proportional to M. मतलब directly depend on the concentration or molarity of the solution, that depends on the solute, correct? So we can say pi is a colligative property. Okay, next, as we have said, the application of colligative property is to determine the molecular mass. तो मेरे पास इक्वेशन है pi v is equal to N2RT, करेक्ट। सो मुझे पता है N2 स्टैंड फॉर W2 अपॉन R, गैस कांस्टेंट है ना, उसके डिफरेंट डिफरेंट वैल्यू याद है, आइडियल गैस इक्वेशन में पढ़ा था हमने। तो यहाँ पे आपका प्रेशर एटीएम में, वॉल्यूम लीटर में है, तो विल यूज आर का वैल्यू 0.0821, दैट इज कांस्टेंट। So if you substitute the value of N2 in this, so we'll have pi V is equal to W2 RT upon M2 into V, sorry अभी नहीं, ठीक है। सो इसको मैं फाइनली लिख सकता हूँ W, the osmotic pressure, is equal to mass of solute multiplied by R multiplied by temperature upon molecular mass of solute multiplied by volume in liter. Volume in liter, please note करो, volume in liter। अगर आप volume ml में लेते हो, if we take the volume in ml, the equation will change to pi is equal to W2 RT multiplied by 1000 upon M2 into volume in ml। So ये फॉर्मूला भी आप यूज कर सकते हो, बट दैट ऑल डिपेंड कि आपने वॉल्यूम किस में लिया है। क्लियर, समझा सबको?